Number 3. Using f of x equals the tangent of x as a guide, graph g of x equals 2 times the tangent of 4x. Identify the period, x-intercepts, and then the asymptotes. Okay, we're going to identify the period, x-intercepts, and asymptotes first. So the period is calculated by doing pi divided by the absolute value of b, and our value of b is 4, so pi over 4. That means one cycle of the graph occurs during a pi over 4 unit. Now calculating the x-intercepts. The formula for this is pi times n divided by the absolute value of b, so over 4. Calculating the asymptotes. The formula for that is pi divided by 2 times the absolute value of b, which is 4, plus pi times n divided by the absolute value of b, which is 4. So we end up with pi over 8 plus pi n all over 4. Now, from there, you can either calculate all the x-intercepts and find the middle of all of those to find your asymptotes, or find the asymptotes and then find the middle of all of those to find the x-intercepts. I'm going to use the formula for x-intercepts to calculate those first. So you may have seen me or Mr. Brasser use a table like this one, where we have values of n that we're plugging in, and then the formula we use to find our x-intercepts, where the graph crosses the x-axis, is pi times n all over 4. So picking some values for n, if I have -2, -1, 0, 1, 2, we'll leave it there for now. So if I plug in -2, I have pi times -2 all over 4, which gets me -pi over 2. If I plug in -1, I end up with -pi over 4. If we plug in 0, we end up at 0. If we plug in 1, we end up at pi over 4. And if we plug in 2, we end up at 2 pi over 4. But that's really pi over 2. Now, if we plug in a larger number, such as maybe 4, okay, you find that, well, here, actually, I'll go back and I'll do 3 first. So if we plug in 3, we get 3 pi over 4. And if we plug in 4, we get 4 pi over 4, in other words, pi. So the pi over 4 tick mark is this one right here that's not labeled, that's in between all these other ones. Those are your pi over 4s. So notice that we know we have an x-intercept at -pi over 2, so right here. We have one at -pi over 4, which is the next tick mark. We have one at 0. We have one at pi over 4, which is right there. So then continuing this at pi over 2, then 3 pi over 4, and at pi, so it's kind of like at every tick mark is where an x-intercept occurs. So you're going to find that this graph is really small and really skinny. Because now the vertical asymptotes, yes, you can go through and calculate them similar to how we calculated the x-intercepts, but truly they just occur at all of the points or at all of the places in between those x-intercepts. So, in between these x-intercepts is a vertical asymptote, and between these ones is another one. So yes, this graph is very, very small. So take a moment to fill in all of these vertical asymptotes. So now once all of your vertical asymptotes are filled in, now you can begin filling in the graph. Okay, so they will start from the bottom left and go up to the top right for your curves for tangent. Make sure that they never touch nor cross those vertical asymptotes. I know that these are pretty skinny graphs, so do your very best. Just remembering that with tangent and cotangent graphs, you really just need to calculate either x-intercepts or the asymptotes, because once you know one of those two items, you can calculate the second one by finding the middle. So here we calculated the x-intercepts first, we plotted all of those, And then we knew where the vertical asymptotes by looking in between each of the x-intercepts, and that's where vertical asymptote was occurring. Okay, and that gives you your graph for the tangent of 2 times the tangent of 4x.